Hello and welcome to an amusingly low-tech Snow Day makeup. We are going to be writing the class notes on the wall here. Yes, I did consider a chalkboard, but I thought that this would be better because I could scan them like normal and it wouldn't really disrupt the flow of the course. Sorry that you don't seem to be able to see my eyes when I'm looking right at the computer. We are going to be looking at section 10, which is about sets. I know you have all seen sets before, but we'll still start by making sure everyone's on the same page in terms of notation and definitions. So first we have the definition of a set is a collection of objects, and not necessarily mathematical objects, just anything. We're just putting together a bunch of stuff. By the way, I do realize that this is backwards. When you have the scanned copies, which I'll attach with this video, you'll be able to see everything right side up and left side left and all that, and then hopefully you'll be able to follow along with what I'm writing and understand how it goes with the video. The stuff in a set, the objects in a set, are called the elements, and we denote this A, little a, is an element of big A. So now at this point, now that you know this convention that usually the big letters are sets or statements, from here on out I'd like you to mostly use small lowercase letters for things like let x be an integer. We don't want capital X to be an integer. Usually capital X is going to be a set of something. There are other conventions for when we use little and big letters moving forward, but now you know this one. This element symbol, I know you guys have seen this before, but this is \n. And the cardinality of a set is going to refer to the number of elements in the set, so the number of little a's in big A. Or the size of a set. We denote this by big bars around A. So this looks just like the divides bar, and now we have one at the left and one at the right. Some people, by the way, have figured out that \mid will give you this bar on LaTeX, but it's also just right on your keyboard, right above Enter. If you hold down Shift, you can get that vertical line. It doesn't display as a vertical line if you put it in text mode, but in math mode, which is where you'd want to do this and where you'd want to write divides, it is going to work out. The cardinality of a set can be any positive integer. It can also be 0 if the set is the empty set, or also called the null set. Then that's a set containing absolutely nothing. There's only one set like this, and it is the null set. Every other set has something in it. So if we have a set of integers that turns out to have no integers, or a set of cattle that turns out to have no cows, those are the exact same sets because both of them have nothing in it. The set of no integers and the set of no cows both have no integers in them and both have no cows in them. So whatever the thing is that is not in the set, if the set has nothing, it is the empty set. There's not an empty set and then another empty set. There's one empty set, and we call it the null set, the empty set, and we denote it by this kind of phi-looking shape. But you still don't want to use the Greek phi. It looks a little bit different than the empty set symbol. What you want to do if you're doing LaTeX is \empty set. If a set has infinitely many elements, there are actually a bunch of different sets like this. There is the set of all real numbers, there's the set of all integers, there's the set of all natural numbers, and those are all different sets. So having infinitely many elements doesn't mean that you have all the elements. Doesn't mean that every single thing is in a set. Remember, cattle can be in a set, Spider-Man can be in a set. Having all the integers doesn't mean you have everything. But if we were talking about the cardinality of the integers, we would say that the cardinality is equal to infinity. And since infinity doesn't really have a value, this is basically a definition. We're basically defining a set that has more elements than any positive integer to have infinitely many elements, and we're defining its cardinality to be that infinity symbol. You get that symbol by doing \inf t, and I think I might have mentioned in your section of the class that it seems like maybe it should be \infinity, and it's not. It's inf t. The easiest way to denote a set is to just give it a name and call it by that name. But a lot of the sets we work with won't start already having names, and so we'll have to define them, we'll have to explain what we're talking about. So we have two different types of set notation that we're going to use. The first one is called list notation, and it just looks like this. Swirly braces. These are notations. We have a swirly brace, and then we'd list the elements. This set contains, say, A, 5, square root of 2, and Elmo. So I've just said everything that's in the set. These things don't have to be related in some natural way. We're just collecting some things and putting them in a collection. It can be your junk drawer. You can put whatever you want into a set and call it a set. If we have infinitely many elements, this gets really, really difficult to do. But if you have infinitely many elements, they must be related in some way. There's no way for us to conceive of an infinite collection of unrelated things. If you're thinking of a collection of things that are infinite, that is an infinitely large collection, then you must be relying on some relationship. And then what we're going to use is set builder notation, which allows us to exploit that relationship to tell the reader what is actually in the set. This is a way to describe finite sets, even to describe very small sets, but list notation is often the easier way to do this. So set builder notation, we still start with a swirly brace, and then we give a dummy variable, x, a, whatever you want, and sometimes at the very beginning we introduce the variable as living in some particular world. So for example, we could say x is an element of the integers. Sometimes we give some superset that it belongs to, some set that we're only drawing elements out of. And then after that you're going to put either a vertical bar or a colon. I'm used to using a vertical bar, and your textbook only uses a colon, so I'm going to try and convert what I'm comfortable with for the purposes of the class, but you'll have to forgive me if I mess up. So we have a colon. That colon, if we're reading aloud, is read as such that. And then we could say x divides 144. So now I've created a list, or I've created a set that contains every single divisor of 144. They were all integers anyway, so this is why I was saying sometimes we'll describe what set the x belongs to and sometimes we won't. We didn't really need to say that x was an element of the integers. We could have just written x such that x divides 144, because that divide relationship isn't defined if something is not an integer. We call this, again, set builder notation. So we're building a set. Again, I said we can do this for finite sets, and this is a finite set. 144 only has so many divisors. So I could also, if I wanted to, list them. I have positive and negative 1, positive and negative 2, positive and negative 3, 4, 6, 9, 12, 24. So you can see why we might not want to list these even though it's finite. Let's see, what else do we have? We have 36, positive and negative. We have 48, positive and negative, and then I think we may finally be done. 144, I'll call it a day. If anyone sees another one, just call out. So even though this is a finite set, it might not be the best set to use list notation for. I can describe sets that we might want to describe in words using this notation as well. I could describe the even numbers by saying x such that 2 divides x. But if I already know how to describe a set in words, sometimes it's actually easier to describe it in words. So I could just write the set swirly braces and write evens inside of that set. So I'm going to describe it by saying x such that 2 divides x, or I could describe it in words by just saying evens. When you're checking this, for all three of these notations, to get these swirly braces, you might have noticed that we're using swirly braces to do things like have an exponent or a subscript that's more than one character, and those swirly braces, the curly braces, they don't display when you compile it. So if you try and do this and just put the curly braces, it's not going to actually show you curly braces. If you want to actually get them, you do backslash and then the brace, and then backslash for the other brace. Anything else that TeX doesn't display when it compiles, like the $, the ampersand, the number symbol, the pound symbol, or hashtag, as you hip kids call it, you do backslash and then you write the symbol, and it'll display it, and it won't act like an and or a $, or whatever it normally does in TeX. If I want to write evens inside of the braces, I'm already in math mode when I do this backslash brace, and so it's going to expect math characters. If I write evens, it's going to write it like the variable e times v times e, and that's not what I'm trying to say. I'm trying to have a word. Once you're in math mode, if you want to display a word, all you have to do is backslash text, and then put the word inside of the text, inside of some curly braces. So you do backslash, text, curly brace, and then you write the word. A lot of the time you'll want to actually include the spaces in there to make sure that the spacing looks appropriate when you're writing in text. Usually you want to have the space before and after the word after you're in text. You don't have to do this in the middle of a paragraph all the time. In display mode, it becomes absolutely vital. And then if you are in the middle of the paragraph and you're writing a set, you probably don't want that set to be broken up into 2 lines. And if you leave math mode, TeX is going to naturally allow it to break into 2 lines. So if you want the set description to be entirely on 1 line, you're going to need it to all be in math mode. And then instead of breaking math mode, we insert text within math mode by doing this backslash text notation. I don't want these videos to be too long because I know that you'll get bored pretty fast and they're not that interesting to look at, and my wall really isn't that interesting. So I'm going to stop now, and then I'll record a second video that will go over some examples of proofs in sets and how we prove certain things with sets. So go take a break, go to the bathroom, get some water. See you in a minute.